Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Looking at virtual work for this particular problem, we want to determine the steepest angle theta and as well as the stability for that position. We have something that look like this. Okay, all right, and so that thing coming down. Okay, that's the weight W. All right, so we have something like this. Okay, and this we call this O. A, we have A, this point A, and this is point B. Okay, now they are given this height is there in the question, and we are given also here, here to here. Okay, the and even up to from here to this point. Okay, between O and okay, this point, this length is also given. Okay, from here to here. Okay, they're actually 1.5, 1.5. Okay, now if we extract AOB, look, we have an angle theta here, but to solve the problem, actually, we will just determine the potential function, differentiate it with respect to theta, and solve the equation to determine theta. All right, that is required. And for the stability, we will take the second derivative of the function with respect to theta, and okay, the potential function with respect to theta, and plug in our theta, then we'll determine the position, okay, by from solving the problem. All right, to extract A, O, B, we're going to have this, something like this, okay, and this is our angle theta, okay, and this O, this is A, this is actually 90 degree. This diagram may not be perfect, that's 90 degree, and if we just trace this like this, we are going to have this one is 3.5 meters. This is 3.5 meters. All right, and this is point B, and this length also is 1.5 meters. And to trace this like this is also theta. This is also theta. All right, so we can also trace this one down. Trace this one down to this point. So this length, this height is also 1.5. Okay, to give us 1.5 1.5 sine theta. Okay, and this height here, here to B. So let me just call here E. I'm just labeling E to B. We are going to have it to be 3 sine 3 cos theta, 3 cos, okay, theta. All right, so for you can just go ahead now. You already know y is going to give us this entire distance, all right, from here to here. So that is y. Now y is going to give us equal to 3.5 cos theta plus 1.5 sine theta. Okay, so that's that about that's what we give us, right? Then for V, we know that V is for what we just have now. We just only have the block, so V is actually just V subscript G, which is the potential uh, gravitational potential energy times Y. So W is the weight there. The mass is 20 megagram. Okay, so when you multiply by 9.81, you are going to arrive at it to be something like this. So it's going to give us minus 20, sorry, 20 times, okay, times 1000 times 9.81, okay, 9.81. So the mass is 20 kilogram, 20 megagram rather, and you multiply by that, you need to convert it to do your conversion, okay, all right. Then we can just plug in our, sorry, we can just plug in our y, which is 3.5, 3.5 cos theta, theta plus 1.5 sin theta. So when we solve this out, we are going to arrive at V to be equal to, okay, it's going to give us, everything is going to give us 6, okay, 8, okay, 6, 8, 6, 7, 0, 0, cos theta, okay, plus 29, 29, 4, 3, 0, 0 sin theta, sin theta. So that's what we're going to have for that. Now, for the equilibrium position, so that's it. We can now take the derivative of the function v with respect to theta. If you do that, we are going to arrive at, of course, we set it to 0. We arrive at minus 6. So it's going to give us minus 6, 8, 6, 7, 0, 0 sin theta plus 2, 9, 9, 4, 300 cos theta. So we just set it to 0, it's equal to 0. All right. So our, okay, so we are going to arrive at, you can see that we have sine and cos there. By the time you do your division, you are going to arrive at a tan. Okay. Okay. You make tan theta to be equal to that value 294300 over 686,700. Then you take your arctan. You take your arctan. You arrive at theta to be equal to 23.2 degrees. 23.2 degrees. So we can also, so that's the position theta for equilibrium. Then we can just for stability, we can just take Okay, differentiate the second time. Okay, so to do that, we're going to have it to be equal to minus 6, 8, 6, 7, 0, 0 cos theta minus 29, 4, 3, 0, 0 sin theta. Sin theta. All right. And of course, we can just sub this out. When you sub this out, we are going to arrive at we should be plugging in our value theta. We're going to have it to be equal to minus 7.47 times 10 raised to the power of 5. You can see that this is clearly less than 0. So the equilibrium is unstable. So theta is 23.2 degree. The equilibrium is unstable.